ready to finish up this lab where we're analyzing the content of a silver-copper alloy. In the end, I want to know what percent of the mass came from silver, what percent of the mass came from copper. And yesterday then, we took that alloy and dissolved it in a solution of nitric acid. And here's what's left. The alloy, the solid, is no longer. It's a beautiful blue solution. Now, there are three main components of this solution. The blue color is copper ions. It's copper plus 2 ions that formed by reacting with the nitric acid. There are colorless silver plus 1 ions in here. And there's some excess nitric acid. We wanted to make sure that we used enough acid to totally react the dime. I didn't want there to be any pieces of solid left over today. And we did good. It's gone, and it's just beautiful. That copper solution is so cool, isn't it? Okay, so now we have to figure out how to separate the blue copper ions from the colorless silver ions. You can't just take this solution and run it through a filter and expect that like some ions will stick on the filter paper and others will drip through. In order to filter, you need a solid and a solution. So we're going to use something called selective precipitation, where we're going to try to precipitate only one of the ions and then leave the other one in solution so that one ion will drip through the filter paper, one ion will stay on the filter paper as a solid. To do that, we're going to use chlorine. Chlorine will form a solid with silver. Silver chloride is a precipitate. That's a solid that forms from the reaction of solutions. But copper chloride is not a precipitate. Copper chloride will stay in solution, so it should run through my filter paper. Now we got to get chlorine ions then into this solution, and the vehicle of getting chlorine ions in the solution will just be salt, sodium chloride. So we want to make sure we add enough chlorine to completely react every silver ion in this solution. I don't want any silver left behind, like going down through my filter paper when we eventually filter. So there's two things we're going to do to ensure that we precipitate every silver ion in the solution. One of them is a little calculation. So I'm in the lab sheet. It's actually analysis question number 1. So I can get it here for you. I might not be able to see it great, but we'll make it work. So it's question number 1. In the analysis, it says to calculate the amount of sodium chloride needed to completely precipitate all the silver in the sample, assuming that the sample was 100% silver, which it was not. Okay, so I need to do a little stoichiometry here. Earlier, we measured the mass of our silver alloy to be 1.30 grams. Well, part of that is copper, but we're going to assume that it's all silver, and we're going to calculate the exact amount of sodium chloride that would be needed to completely react all of that alloy if it would have been 1.30 grams of pure silver. Now, jumping ahead a little bit to the next unit, whenever we do stoichiometry, we need the balanced equation. Here's kind of the equation. Here's the reaction that's happening. It's going to be the sodium chloride. Sodium is +1, chlorine is -1. Reacting with the silver ions in the solution, they will be +1. You may have called this like a replacement last year, single replacement or displacement. It's kind of like that, where the sodium chloride is going to be in solution. We're going to make a salt solution. And then the silver is also aqueous. It's in solution. So do you kind of remember these replacement reactions or displacement, where like charged ions can switch spots with one another? And so here my silver and sodium are going to switch spots. And so eventually I'm going to form silver chloride, which will be my solid that I can filter. And then I'll have sodium plus 1 ions that will be aqueous. And so those sodium ions will just go right through the filter paper. I don't want to collect the silver, so the silver is going to eventually go down the drain. It's really just a way of getting chlorine into the solution. I could have used potassium chloride. Any chloride would have been fine. So the important thing to know about the balanced equation is that because the sodium and the silver are each plus 1, the equation is balanced. I mean, like the silver chloride is plus 1, minus 1. So everything is a 1-to-1 ratio. You will not need to write any reactions or equations on this unit's test. That's the next one. Okay, so then I'm going to start with this 1.30. But I'm going to assume that the mass was entirely silver. It was not, but we're making an assumption that it was. Now, if it was silver, I want to know how much sodium chloride I need. Well, I can't compare these two substances when the amount is in grams. They'll have very different masses. So anytime you're starting stoichiometry with an amount in grams, we got to get it out of grams and into moles. Moles of silver. Anytime I see mole, it's a 1. And anytime I see grams, I'm going to my periodic table. Oh, let's see. There's one on the lab wall. 107.87. Molar mass of silver. 0.87. Grams and grams of silver are out. Now that I'm in moles, I can switch to any other substance in the reaction. I want to know how much sodium chloride I need. And so I totally get that this proportion is not going to change my final mathematical answer, but I'm kind of a freak about my units canceling. And so I really enjoy this part. It's a 1-to-1 mole ratio. That would be the ratio from the balanced equation. Moles of silver are out. So now I'm in moles of sodium chloride, but I want to be able to measure this mass in grams. So we do this one more time. I'm going to cancel moles of sodium chloride and put it back in grams. Notice that when I do stoichiometry, I always put my units in first, then I get the numbers in the right spot. 1 mole of sodium chloride has the mass on the periodic table. So I just have to add a sodium plus a chlorine. Got it. 58.44 grams. Cool. Okay, so now moles and moles are out. And all we got to do is multiply anything on the top, divide by anything on the bottom. 1.3 divided by 107.87 times 58.44. Okay. And I'm looking at about 0.7, I guess technically it's 704 grams of sodium chloride. Okay, number 1, that already puts chlorine in excess because we assumed that the 1.3 grams was all silver, and it's not. I mean, there's, I don't know, maybe like 1 gram of silver. It's less than 1.3 because some of this mass is copper. So if I measure 0.704 grams of sodium chloride, that's already excess chlorine. And I don't really care about the sodium. But then if you read in the lab sheet, it says to calculate the amount needed and then double it. So if I double this times 2, it's like 1.41 grams of sodium chloride. That's way excess. That's way more than what I need. It's over twice as much chlorine as what I really need, but it's going to ensure that every single silver ion will be precipitated. Okay, so let's do it then. I'm going to go to my electronic balance. We'll add the weigh boat. We'll zero it. And then we're going to put in about 1.40 grams of sodium chloride. Okay. And even this doesn't have to be perfect. Well, 1.8. That's a little more than what I need. I'm at like, what, 1.7? I guess I should take some of that off, huh? There we go, 1.40 on the head. But I don't need to measure, I don't need to record this mass. It's way more than what I eventually need. Then we're going to dissolve it in a little distilled water. So a little more than 20, maybe 25 milliliters of distilled water. We'll add the sodium chloride. And this should dissolve pretty quickly. We'll swirl it around a little bit. And then I've got my salt solution, my excess chlorine. The sodium is what we're eventually going to call a spectator ion. It's an ion that's present, but it's not doing anything. It's not really part of any chemical reaction. See, that looks pretty good, huh? Pretty dissolved. So then I take my salt solution, and I'm going to add it to my pretty blue copper silver solution. And this is exactly what I expected. I was hoping that a precipitate would form. A precipitate is a solid. So I don't know if you can kind of tell that there's a white solid in there. You can kind of see it down at the bottom. There's definitely white solid. And then there's kind of this milky blue solution in the background. Well, that's still the copper ions. They're in there. They are not changing in any way. Copper does not react with silver ions. Cool. All right, so we swirl this around a little bit, make sure that it reacts fully. And now all we have to do is filter. Now, I bet last year you filtered quite a bit when you were doing stoichiometry, or hopefully you did. Ooh, look at how nice that's chunking. See, there's like some really nice white chunks in there. Filtering is like a test of your patience, where you take your filter paper and you have a funnel and a flask and you let it drip, drip, drip. Well, boy, do I have a treat for you. We're going to do something called vacuum filter. And you're going to say, why didn't we do this last year? Well, say, I don't know. We probably could have, but we just didn't. So here's going to be my filtration apparatus. There it is. So it's a flask. And on top, there's this little cup. And it only fits really teeny tiny filter papers. So here's my little teeny tiny filter paper. We're going to record the mass of the filter paper. So I'll put that back on my electronic balance. And this number I do need to record. So let's make sure that was, yeah, I guess it's pretty close to 0.18. So this number I am recording. 0.109. And I guess it does ask, now that I'm looking at the lab data, it does ask for the exact mass of sodium chloride used. I used 1.40. We're never going to use that number in our calculations, but I'll write it down. And now I got my filter paper. It's 0.19 grams. So they're little teeny tiny filter papers. But they fit perfectly on top of this filtration apparatus. So up on the top, you kind of see there's little teeny tiny holes in there. And so this guy goes on top. And then, have you ever noticed there's these little like goofy spouts on some of the sinks in the chem lab? And you're like, what are these things? They're for vacuum filtration. So here's what you do. You're going to turn the water on full blast. When you have a stream of moving particles, they go from an area of high pressure to low pressure. Well, we're creating a low pressure situation in here where there's less pressure outside, more pressure inside. And so if I put my hand on top, sometimes, if my hand fits good, like I can feel that it's sucking my hand on there. Kind of cool. It creates a vacuum in a sense. Yes. And so all we got to do now is take our solution, swirl it around a little bit, and watch how quickly it filters. It's sucking the water, or I should say the solution through in minutes, seconds. How crazy is that? No more waiting for drips to drop. And now really what we should do when we're filtering, this came out really nicely, but there's not a whole lot of solid left in here. But we should always add a little more distilled water. Swirl, where's my camera? Swirl it around and then send that through again, just to make sure that I got all of the solid out of the beaker. It looks pretty clean. That's sending through one more time. They also mention adding a little dilute nitric acid, just to make sure that my precipitate doesn't get to be like fine particles that would eventually go through the filter paper. And then we're going to rinse this with a little more distilled water. Make sure I get all that extra acid out. I don't want any copper up here. I don't want any excess nitric acid. I only want silver chloride. Nice. And it's almost done. Isn't that crazy? It's like less than a minute. Why didn't we do that last year? Life-changing. Okay, that looks good. So now we turn it off and you like make a huge mess. There's like water all over the table, but that's fine. It's water. Okay, then we're going to get a piece of paper towel. Just like last year, we need to get this thing out. And so you have to be like a surgeon. Oh, let's see if we can use this. So we're going to go in and try to get the filter paper out and not lose any of this precipitate. Sometimes you have to kind of like roll it up like a taco, I think. Come on out. Okay, here it goes. And then I put that on just a piece of paper towel. And now we're going to put that in the fume hood and let it dry so that we can mass it tomorrow. Now, one other thing that we should just make note of, I don't know if you can kind of tell, here's the solution in the bottom of the flask. Whoa, where is it? Here it is. If I put it up against the paper towel, like the white paper towel, can you kind of tell that there's still a blue tint to it? I mean, it's obviously a lot diluted because we added all this extra distilled water as we were washing the precipitate. But you can usually kind of still tell, there it is, that there's a little bit of a blue tint. That's still where the copper ions are. They're in the bottom of, get in there. They're in the bottom of this flask, which now I'm just going to dump down the drain. I don't want to keep the copper, and I don't want to keep the excess chlorine. I don't want to keep the sodium, and there may be a little excess nitric acid, but that's going down the drain. I'm only keeping the silver chloride precipitate. So this guy goes in the fume hood. We'll let it dry, and then we'll mass it tomorrow.